Hey geometry students, welcome to the lesson for 11.3. You can find it on those pages listed there. This is stuff we've learned before, but just some vocabulary you need to know again for this lesson: what the perimeter of a polygon is, the area of a polygon, and area of similar polygons is more specific to this lesson. And so we are talking about perimeters and areas of similar figures. So there is a theorem, theorem 11.5, that we'll write down here to start. This is the big guy for this lesson. The areas of similar polygons is the name of this theorem. And this goes by theorem 11.5 in our book. And it says that if two polygons are similar, with the lengths, I'm going to abbreviate corresponding with COOR, corresponding sides. This is sides in the ratio A to B, so it's in that ratio. Then the ratio of their areas, it's not the same. It's going to be A squared to B squared. So if the sides are in this ratio, the areas are going to be in this ratio. And that should make sense if you think of a square. If we draw a square, don't draw this off to the side here, but if the side length was 6, all the sides would be the same, but this would be 6 times 6, 36. And so the ratio of areas is going to be different than the ratio of the sides, because area is 2 units multiplied together. So you have A squared and B squared instead. That's kind of leading us into this first example here. Well, let's say you had two pentagons, one a good deal bigger than the other one, but they're similar, so they have the same shape, same basic shape there and there. It kind of looks like the home plate of a baseball diamond or a softball diamond. And we're going to say this is zebra, and this is joust. And we're going to assume that these are similar shapes. So we're going to say that this is 2 right here, and that this side length is 3 right here. So is it possible to ride a zebra? I had that question posed to me one time, and it looks like yes, it's possible. Unless this picture is photoshopped, I don't think so. I think that it is possible to actually ride a zebra, to tame one and to saddle him up. This guy doesn't have a saddle though, he's just going bareback on that thing. But for this one, let's assume that was true, that the two shapes are actually similar. If zebra, remember that from a while back, that just means is similar to. If zebra is similar to joust, then since the ratio of the sides is, it looks like in this case it's 3 to 2, and the ratio of the areas is going to be 3 squared to 2 squared, which is the same thing as 9 to 4. And so if you were asked, I kind of left that question out, but if you were asked that question, what is the ratio of their areas, if they're similar, you would say it's 3 squared to 2 squared, which is 9 to 4. So I think pretty straightforward, pretty easy problem to tackle there. Let's check out another example though. So let's say now a rectangular tablecloth measuring 60 inches by 120 inches is, we'll call it X dollars. We don't know how many dollars, so we'll say it X dollars. And a 12-inch by 24-inch placemat, so much smaller, it's just the placemat, is $5. What's a fair price for the tablecloth? And by fair, I mean if it's going to be the same cost per square inch, assuming that. It might actually be a little bit less, so what's the most though that you would pay and still say, hey, that's the same price per square inch, that's a fair price. And so I think this was kind of funny. I just threw that in there. This unsuspecting kitten was killed by an ugly tablecloth. I've seen some pretty bad tablecloths before, some pretty ugly ones. Maybe you have too, I don't know. With details to come in film at the 11 o'clock news, I would assume that would be. Okay, so in this one, the ratio of, we didn't talk about this yet here. Let's just mention it in the context of this one. So the ratio changing my mind. So corresponding sides with this, let's put or perimeters. It works for both. So sides or perimeters, if they're in this ratio A to B, then the ratio of their areas is going to be A squared to B squared. And so here the ratio of the perimeters it's the same thing. It is corresponding sides or perimeters, but the ratio of the sides, I'll put sides slash perimeters because they're both the same. So if I were to figure out the ratio of the perimeter or the perimeter of this actual tablecloth, I would do 60 plus 120 plus 60 plus 120. And I could do that here as well, but if I compare matching up sides, it should be the same. So the ratio of the sides or perimeters is going to equal, it would be 12 to 60, or it would be 24 to 120. And if these are similar, they should both be the same. They both are the same. They both reduce down to 1 to 5, a 1 to 5 ratio here. So I can divide these both by 12 and get 1 to 5. If I divide both of these by 24, I get 1 to 5 as well. And so here the ratio of the areas, how many times bigger is the tablecloth compared to the placemat? How many placemats could you fit inside the tablecloth is another good way to think of that. The ratio of the areas is going to be 1 squared to 5 squared, which is just 1 to 25. So the tablecloth is actually 25 times bigger in terms of area. So that's pretty important. This is the ratio of the areas. This was the ratio of the sides or the perimeters. But what's the fair price? That's the question asked. So the tablecloth should cost, I would say should cost no more than, if it's going to be the same price per square inch of the placemat, it should cost no more than 5 times this 25. It's 25 times bigger, and the placemat cost $5, so it should not be any more than $125. So I would say no more than $125 at the same price. Per square inch. If you want an alternate way to think of this, think of it like this. I do want you to write this down for me. This would be your placemat. This is not drawn to scale, but this would be like 12 inches and 24 inches. The tablecloth should be a lot bigger, but still that same shape of rectangle, or the height. And it's a little too long, I would say. Actually, I want the the length to be about twice as big as the width or the height of that. There we go, it looks a little better. And so I'm saying this is 60, this is 120. We could set up a proportion. So I'll say this is another method, another way to think of this would be, you could say this 1 to 25 ratio would equal, because it's not always going to be as easy as just multiplying two numbers together. Sometimes the ratio of the areas might not be quite so nice, or it's just a 1 to something comparison. So this would be $5 to X dollars. And if we cross multiplied that, let's show that in a different color so you don't think I'm crossing out the equal sign. So cross multiplying that, this would give us 125 would equal, it's the 5 times 25, I'm sorry, 5 times 25 would equal X, $125 in that case right there. So either way you think of it, it's going to work out like that. And example 3. Here's the situation for example 3. A store sells trampolines. Nice trampolines. Always fun. Always a good time. Just don't hit your head on the side or fall off the thing. Sells trampolines that are all regular hexagons. And before you say, that's crazy, I've never seen a regular hexagon trampoline before. Now you have! There is a regular hexagon trampoline. Yes, they exist. They're not always circles. You can also buy regular octagon trampolines. One trampoline has a side length of about 4.5 feet and an area of about 52.6 feet squared. What we're going to try to do is find the area of a trampoline whose perimeter is 67.5 feet. And so first you have to decide, well, which one's bigger? Is it this first one you're talking about, the length of 4.5 feet, or is it the second one whose perimeter is 67.5 feet? So I'm going to split this space down here into two parts, and I'm going to put the smaller trampoline over here. I'm going to put the bigger one over here. And let's use our calculator to decide. I know these are hexagon trampolines, and I know the perimeter of the trampoline, the second trampoline in question, is 67.5. So if I took 67.5 and divided it by 6, that would give me the length, the side length for each one of the sides for this trampoline. It would be 11.25. And so I know this one would actually be the bigger trampoline by quite a bit. 4.5 feet length versus 11.25 feet length, foot lengths. So let's draw in our best regular hexagons. Freehand if you want. So I've got a smaller one and a bigger one. It's not going to be drawn perfectly to scale here. You could if you wanted to, but I'm not making it. And so the smaller one, the bigger one, the side length, we know in this one, this is my solution here, so let's put that SOLN for solution. The side length is 4.5 approximately, it says. It's about that, 4.5 feet. And the area is approximately 52.6 feet squared. And with the bigger one, says the perimeter is 67.5 feet. The area we don't know, so the area I'm going to put with a question mark right there. But with this one, we could easily figure out the perimeter. Since the side length is this, we could say the perimeter is going to equal 4.5 times 6, which would be 27 feet. So the perimeter of this one, not a final answer, but I'll circle that, it's pretty important, is 27 feet. And so now the idea of the ratio of the sides being the same as the ratio of the perimeters really comes in handy. Knowing that that is the case, I use that here, oops, went too far, and I can say then that the ratio of the perimeters which is the same as the ratio of the sides. Why don't I actually put that in like I had done in the previous one. I'll put sides slash perimeters. Ratio of the sides slash perimeters, they're the same. So I could have used that the side length here was 11.25 and done 4.5 divided by 11.25. I could have done that idea as well, but the ratio of the sides or perimeters, I'm going to say from the bigger one compared to the smaller one, it would be 67.5 over 27. If you put that into a calculator, you're going to get 2.5. And you can think of that as 2.5 over 1. So you can think of it like that, or you can think of it as something like that too. So 2.5 to 1 would be how that would work out. Okay, so we could say that that's actually the same as, I'm not going to write this down, it's actually the same as 5 to 2. We could make that a fraction that way as well and say it's 5 to 2. So the ratio of the areas that would equal this 2.5 squared to 1 squared, which would equal, that's the ratio of the sides here, that would be 2.5 squared is 6.25 compared to 1. And so I used decimals in this, that's okay. If I would have gone with 5 halves, which is equivalent to 2.5 over 1, I would have had 25 compared to 4. So I could use 25 over 4. I could also use 6.25 over 1 like I've done here. And so I need to have one more page here. So the area of the larger trampoline is going to equal, we can think of it as 52.6 because that was the area of the smaller one. And since it's in this to 1 ratio, it's just 6.25 times bigger than the smaller one, we can simply multiply this by 6.25 to get our answer. This would be approximately 328.8 feet squared would be the area of that one. And then lastly, I want to put that alternate method. If we'd have used the 5 over 2 instead, I definitely think this would have been the way to go. Since I did figure out how many times bigger it was in terms of a decimal in this case, I think this worked out pretty smoothly, pretty nicely. But we could also say that the bigger area compared to the smaller area, x compared to 52.6, would have to equal the bigger area to the smaller area ratio. So we could set it up like that, cross multiply, and say that x would equal 52.6 times 6.25, just like we saw up here before, which would be 328.8 feet squared. Alright, so that will do it for us for this lesson. Just remember the big thing, the big guy, the big kahuna here. A to B is the ratio of the sides or perimeters. The ratio of the areas will be related in this way instead, A squared to B squared. And go ride a zebra.